Hey guys, STAT1150. Let me tell you what's going on this week. We're a little bit ahead, and so I've decided to step back a little bit and review the two broader topics, confidence intervals and central limit theorem, that we've been covering about the last 2 to 3 weeks. Let me tell you why. Year in, year out, when I teach this class, the confidence intervals and the central limit theorem problems are the ones that are most commonly missed on the final exam. So I thought, well, let's take a little different approach this time and let's go through the confidence intervals and central limit theorem a little quicker at first, but that gives us an opportunity to kind of step back and spend more time in review. I think it's going to work better. I won't get into the whole pedagogy and the theory that's behind this, but ultimately, let's say you missed a couple or three or 10, whatever it may be, problems previously. Hopefully, this review session will tighten up your understanding of this material and get you to where you score better on it on the final exam. Because ultimately, that's what I mean. Those points are huge value in terms of contribution to your final grade. Where homework problems, each individual homework problem, although collectively they make obviously a big difference, not as much as the problems on the homework or on the final exam. So that's the purpose. Stepping back, good news. There is only going to be one video this week, and there's the MyMathLab or MyStatLab assignment's been posted. Has a lot of problems that you've seen before. Now, there's a few new problems thrown in there too. But anyway, this week's homework assignment on MyStatLab will be all review, and hopefully this handout will help you learn, possibly even relearn some of the material. At least it's going to give you an opportunity to practice it again. Because again, guys, I've taught this class over 100 times. The central limit theorem problems, especially for the proportion problems, are the most commonly missed problems on my final exams. So this is kind of geared toward addressing that problem. All right, gang, you'll see right here that I have a handout. And if you'll go to the content folder titled Handouts, at the very bottom, you'll see a handout called, or a file called Review CIs and CLTHm. So in other words, review confidence intervals and central limit theorem. I think there are 12 questions total. So what I'm going to do is I'm going to split this into two videos. Really, it's just one big video, but I think it's better to split these things into two videos. So I'm going to do 5 problems in the first video and the remaining problems in the second. So let's get it going. Guys, one thing that we want to do is, I really should have already had this done, is I want to go into, shoot, I thought I had that up. I want to go to MyMathLab and sign in. So this is for STAT1150 in the fall, but it's very, very possible I'll use this video for future classes. All right, so let's go to StatCrunch because that's the way we're gonna use technology to work these problems. All right, so gang, we are ready to go. So let's kind of minimize this so I can maximize this. All right, so I hope that's big enough. So again, it's the beauty of being able to print out the document. So the first question says, of 1,892 adults surveyed, 461 said they would prefer a girl if they could only have one child. Construct and interpret the 95% confidence interval. So guys, what I see here is I see that our sample proportion P hat, which is our X over N, is 461. out of 1892. So I want to take this value, I want to build margin of error around it and create a confidence interval. And in this case, I want to construct a 95% confidence interval and then provide the interpretation. Well, guys, the lucky thing is you guys are get it pretty easy here because StatCrunch does these types of problems, pretty straightforwardly. So I want to go to a one sample with summary. So number of successes in this case would be saying that you wanted to have a girl if you only had one child. And there were 1,892 total that were sampled. And the confidence interval for P is 0.95. So when I compute that, I see that my lower limit is 0.224. And the upper limit is 0.263. Sometimes it's easier to think about this in terms of percentages. So our confidence interval ranges from 22.4% to 26.3%. So now the interpretation, we would say that at a 0.95 probability, the percentage of all adults who would have prefer a girl if they could only have one child is somewhere between 22.4% and 26.3%. Problem number 2, a university representative claims that the average annual driving distance for college students is 12,000 miles. You question this claim and would like to test it using a 95% confidence interval. You collect data on a random sample of 100 students. For these 100 students, they drive 11,878 miles and a standard deviation of 3577. So guys, what you've got here is you have a T interval. The population standard deviation isn't given. So I'm going to go to T-stat, one sample, and I have a summary. So guys, the sample mean here is 11,878. The sample standard deviation is 3577. And our sample size is 100. We want to construct a 95% confidence interval. And we see that we get 11,168. It's a little confusing because that comma right there with the 11,168 is a little confusing, but we should be able to handle that. So 588. So I'm going to underline these just to make them kind of stick out. So the 95% confidence interval says that the average, at 0.95 probability, that the average distance driven by all students is somewhere between 11,168 and 12,588. Now, the claim of 12,000 is in this interval, so we have no reason to reject the claim by the university representative. So in testing it, we can't refute his or her claim. Question number 3, Coke cans are filled so the actual amounts have a mean of 12 ounces and a standard deviation of 0.11 ounces. Find the probability that a randomly selected can will have at least, now guys remember at least means more. So, again, I remember missing a problem like this in my first statistics class, and it was a lesson well learned. If somebody walks into the room and they're at least 6 foot tall, it means they're 6 foot tall or higher, 6 foot or more. So I guess sometimes at least it's easy to think of that as less than, but it's not. Well, guys, you've got a calculator for this. So we need a normal calculator. So I think that's under Stat, Calculator, go to Normal. And we have a mean of 12 and a standard deviation of 0.11. So we want more than 12.19. Right? Yeah. compute, so the probability is 0.042. Now, find the probability that a random sample of 36 cans. So guys, this means that we change from the sample standard deviation to the standard error. We'll have a mean of at least 12.19. Now guys, this is the same problem, except I have to come in here and divide by the square root of 36 instead of just using the 0.11. Anytime I take a probability of a mean instead of a probability of a single score, I have to change the standard error to the I have to change the standard deviation to the standard error. So the problem's the same otherwise, except you're going to see we get a very low answer. Now, this doesn't mean that this couldn't happen. What this is telling you is that the number of zeros here, it's probably like 0.00000. Imagine I said like 17 zeros. And you know, you might say there's still a chance. But StatCrunch doesn't report it out that far. And when it gets out to a certain level, it's so low that it just reports it as 0. So guys, not very likely that you're going to get, it's not really likely you're going to get one can of more than 12.19 ounces. But to get 36 that have an average of 12.19 or higher, it's very, very, very unlikely. All right, number 4, an expert claims that 60% of Americans believe that government regulations of businesses does more harm than good. Nothing like a little politically infused question. You collect a random sample of 1762 adults. What is the probability that more than 1,090 of those sampled believes the government regulation of businesses does more harm than good? So essentially, guys, what you got to look at here is you got to find the mean of the p-hat, which is the percentage that you're given that describes your population. Then you have to find the standard error of the p-hat. This is 0.6 times 0.4 over the sample size. So our sample size is 1762. And some people find it easier to just go ahead and use their calculator and calculate that value. Now let me show you what a lot of you are doing. And I pointed this out in the video, but it's still so tempting to do it. You're taking the square root of the 0.6 times the 0.4, well, how about times? Fine, okay, you're doing that well. But then you're coming in and doing something goofy. I don't know why, because I told you not to do this. Divided by the sample size of 1762. Guys, that's not what this says. This says that everything is under the square root. And when you type it this way, now this operating system with the calculator kind of makes it obvious. But some operating systems don't. So guys, what you got to do is you got to go back here and delete all that out. Get back underneath the radical sign. And then divide by making sure that everything is under the square root of 1762. Now, as long as I take this and report it out to about 5 digits, I can use this value. What is that, 6, 7? You know, the light's kind of shining on it, kind of, yeah. So you can take it out to 5 or 6 digits. Now, if you just go to maybe 0.01, you're not going to have enough representation of this standard error to get an accurate answer when we put it into StatCrunch. Now our p-hat here. So many of you just want to put that 1090 in there. But guys, that's 1090 out of the 1762. So guys, when we go over to StatCrunch here, we have a mean of 0.60. We have a standard error of 0.01167. And we want what? Probability that more than, greater than 1090 out of the 1762. I don't know how many emails I got from people who just put that 1090 there. And think it through, guys. If your mean is 0.6, how can what you're trying to find be 1090? This is a percentage. This is a count. You have to have a count out of the whole to make a percentage, a proportion. So if your parameters are given in terms of a proportion, what you're actually finding the probability of has to be in a proportion. So guys, the answer here would be 0.055. And I'm rounding to 3 places. If StatCrunch tells you to round to 72 places, round to 72 places. It won't, because that would be ridiculous. But however many places StatCrunch tells you to round to, then follow those instructions. All right, BMW advertises that repair costs to their vehicles that are crashed under normal conditions is approximately $1,000. Because of the obvious expense involved, BMW selects only 5 cars for crash testing. The repair costs for the 5 crashes are given. You feel the mean repair costs for repairing a crashed BMW. It just makes me uneasy talking about a crashed BMW, but anyway, it's actually higher, and would like to use sample data in a 95% confidence interval to test their advertised value. We'll assume the population of repair cost is approximately normally distributed. Well, gang, what I'm going to do here is I'm going to type these numbers into the first column. So 897, 1147, 1085, 1096, and 1105. All right. So since the population standard deviation is not given, I'm going to use the t-distribution, one sample, and guys, I have my data. So I'm going to select that. I am going to do a confidence interval, 95%, and I'm going to compute. So the lower limit is 945.13. And the upper limit is 1186.87. Now we ask ourselves, is $1,000 in the interval? And it is, right? So from our confidence interval, we can't reject their claim of $1,000. There's not sufficient evidence from this sample data to refute or to bring concern to, if you will, the claim of $1,000. So guys, I hope this review is helping. I don't, whether you say it is or isn't, I think it will. The central limit theorem problems are the toughest problems that we encounter the entire semester. So looking at them again, along with confidence intervals, I think will be helpful. All right, guys. I set out at first probably to just do one video, but I think I'm going to split it into 2 smaller videos. So take care.